Hello, everybody. Feeling just awful, so going to take notes today on ellipses. We were going to do this yesterday, but the picnic was there. So, what is an ellipse? Well, man, we're kind of running out of time, but there's all kinds of cool things you can do to create an ellipse. But Won't be able to do that this year. Maybe we can save it for next year. But in ellipse, we kind of went through how if you slice the conic section, then you'll get an ellipse. But it's also the locus of points such that the sum of the distance from any point on the ellipse to two fixed points remains constant. So these fixed points are actually just called the foci, okay, or the focus. Okay, the foci is plural of focus. All right. So what happens is that this distance here, d1 plus d2, remains the same. So if you can kind of imagine a string, I'll put the link actually in Schoology, but there's this nice little video where, you can kind of like, if this is connected to a string, you put your pen against it, and then d1 plus d2 have to remain constant. So what are the parts of an ellipse? Well, the major axis is the longer axis. Okay, and I'm going to keep this real brief. I'm going to try to. This guy's the shorter axis. Okay, now with a circle, they're the same, right? A circle, both its major and the minor axis are the same distance, so we just call that a diameter. But with an ellipse, we have two different axes. Now, here's where they intersect. Intersection of axes. Okay, now the vertices and co-vertices. Now this is the end. These are the endpoints of major axis. Okay, and then co-vertices are the endpoints of the minor axis. Okay, so you're going to have to find those after you graph them. Now, typically we just call horizontal means it's more kind of sat upon like this. This looks like it's more pulled upwards. And so the vertices are basically, well, plus or minus A. And then the co-vertices are plus or minus B. We'll get into that in a second once you see the standard form. The length of the major axis is actually going to be 2A. So A this way, A that way. And then the foci, this guy is 2B. Then the foci is going to be plus or minus C. We'll talk about C in a second. But let's label these right here. So you've got the focus here. Here's the other one. Okay, that would be where you stuck your pins in for that string there. Okay, this guy's the major axis. This guy would be the minor. I'm sick. All right, that's why the line is like that. So I don't want to hear it. And this is the center. All right, this guy would be the co-vertex. Okay, and this would be a vertex. There's two of them though. Not co-vertex, vertex. Okay, this would be a vertex. And then this would also be a co-vertex, okay? All right, and this applies to this as well, right? The only thing that's changed is that now the co-vertices are here and here, and the vertex is here and here. But notice that the foci are always on the major axis, okay? Foci are always on the major axis. Is that mentioned in the notes there? Okay, it's not. So let's put foci on major axis. All right, now the standard form, here, the formula to find C, this is the foci. This guy is actually C squared equals A squared minus B squared. Now, where does the A and B come from? Okay, well, let's look at the form. What you got is you got an X minus H squared plus an Y minus K squared. But here's where it's a little different. You are not going to equal some value here. Okay, it's not going to be R squared. It's actually going to be 1. It has to be 1, actually. And what happens, this is a lot easier to graph when it's like this. You have an A and a B squared underneath each of these coordinates. And what it does is it creates the wobble effect, okay? It forms the squishing of one of the axes and versus the other. Now this can switch up so that you can have actually b squared underneath the x, because remember a is actually the major axis, okay? So a should always be the larger number. So if the x has a smaller number, then that has to be b. But notice that we've pretty much got the same form here, almost as a circle, right? It's just a little different, okay? Just slightly different because of the fractions, and it equals 1. Okay, so what does this look like when we graph it? All right, so when you graph it in an ellipse, I enjoy these. I love comic sections. All right, you want to write the equation in standard form. You graph the center, then you do the vertices, then the co-vertices, and then use this formula to actually find the foci. Okay, now the foci are going to come off the center. So we're going to be able to do this, and we'll actually do these 3 problems, and then you'll be on your own here. Okay, in fact, what I'm going to do is I'm going to stop just because we're at the 6-minute mark. It's easy to upload. It's like that. We'll do these problems on the next video.